All right, we are kicking off our first segment of the Friday today with Alex. Alex, welcome to the show. Please introduce yourself.
Hi, thanks for having me. I'm Alex Yankolski. I'm a principal solutions architect in the worldwide specialist organization at AWS, and I focus on orchestration of ML and AI workloads on AWS using containers. So that's just a fancy way of saying I like to run stuff in containers at scale.
So you said worldwide specialist. So you are a containers specialist. You know everything about how to containerize and scale on AWS.
Um, I like to run everything in containers. I'm not in the container specialist organization, but I'm in the frameworks team, and I'm generally in the worldwide specialist organization that has many different specialists that um, specialize in deep in areas of the entire Gen AI stack on AWS. Um,
Interesting.
yeah,
Interesting. Yeah, I knew we had some divisions inside, but I didn't know we had specialists on uh hyper focusing on that. So welcome to the show. Thank you for spending some time with us. But before we go on, Alex, what is your favorite fall theme drink? Do you have one?
I actually don't have a favorite. I like many of the full drinks. I like pumpkin spice. I uh, I'm happy to try anything new. I like new experiences.
Awesome.
Hey,
Awesome.
maybe
Thank
we
you
can
so
I think we're going to be talking about some fine tuning some models, so maybe we can kind of get some new flavor suggestions through SageMaker. But Alex, you mentioned containers. When I think containers, I think Kubernetes, right? I think Docker, I think Kubernetes, and we have a service here at AWS that does some of that work for you. And I think we're going to be talking about that a little bit. Can we talk about? Can you introduce the topic and what we're going to be getting into today?
Yeah. So the challenge is models. As you said, models are getting bigger and bigger, and especially foundation models require intensive training with specialized infrastructure and accelerated compute at scales that are, in the thousands and of tens and hundreds of thousands of accelerators. Um, and that is to support the size of models, which is now in the billions of parameters, and going towards trillion parameters and beyond. So at that scale, first of all, it's very expensive to do. And second of all, if a hardware failure occurs, and anyone that's run hardware knows that hardware fails sometimes. When hardware failure occurs, it is very expensive to stop the job, to troubleshoot where the failure is, to remediate it. It could take hours to do that manually, which equates to longer training times and um, lower utilization because all of the accelerators that are just sitting idle are just incurring cost while not being used. So that is why, listening to our customers, we built SageMaker HyperPod, which is a service that automatically monitors and detects hardware failures in large scale infrastructure and remediates them on behalf of the customer. And this week, we released Amazon EKS support for SageMaker HyperPod, which now means that you can consume the HyperPod service through the very popular Kubernetes interface.
I got it. So we're talking. This is done through SageMaker. And Alex, I'm sure we've mentioned this already. We're a live show, so we actually have audience asking in questions. We got our first question in the channel, so I just want to take a minute to make sure we get to that. The question is, what are some of the most innovative or unexpected use cases you've seen with Amazon SageMaker in industries like cybersecurity or cloud optimization? Whew, that's a question.
That's a good one.
Wow.
Yeah, yeah, we tend to get some
Unusual, innovative,
Yeah.
innovative or unexpected use cases. What anything that like models might be trained for? I mean, I know I saw something recently on protein folding for drug research. That's models that I've seen a bunch of stuff about sports, like I said, because I've been all these new tackle statistics that are being launched in the NFL. Those are some of the ones that I've seen that are really cool. Alex, do you have anything?
Yeah. Gen AI and deep learning has permeated every level of life, and use cases, as you mentioned, from protein folding to um, computational fluid dynamics and healthcare. Security is actually a tough one, but fraud detection in the financial industry, autonomous driving, that's a really cool one. And content creation. Art is never going to be the same anymore. So use cases are really cool, and they're all enabled by this new advancement in generative AI that we're seeing in life.
That's right. If you want to do that at scale, SageMaker is one of those services that can handle that kind of capacity. We've got another question in the chat. Like, at what scale, is there a scale in these models where we start hitting diminishing returns on the number of parameters? I know these models are getting bigger and bigger and bigger. I don't know if there's such a thing as diminishing. I imagine it's somewhat correlated to the amount of computational power that can sit behind it. But Alex, what do you think about that?
I think we're still in the beginning of the journey. The scale we're seeing now is still difficult to compare to the capacity of the human brain in terms of number of neurons that we have in the brain. So it's a balancing act. The returns that you're seeing and the investment you're doing, but hardware and networking is getting better, and the models are getting bigger. So hopefully we're able to move both of these in the same direction together.
Nice. Alex, that kind of brings me into just kind of wanting to better understand what this is going to look like. In my mind's eye, coming from an ops and data center background, I have an idea of what the service would potentially do based on the way that you described it and the complexities therein, and make sure that we get the scaling right without, taking false positives and taking action when we don't need to. Any chance you happen to have a demo of what this looks like and be able to walk us through it?
Yeah, let me do a quick screen share here and pull up. First, I have a slide that I can show you to kind of describe what it looks like in terms of architecture. So, as mentioned, SageMaker HyperPod is a managed service, which means that your compute nodes actually live in a managed account, and that's where they're being monitored, deep health checked, and constantly observed for any hardware failures that might arise. And when they do arise, there are workflows that remediate those failures for you quickly. Nodes get either rebooted or replaced depending on the type of failure that's occurred. This service, this compute can be consumed either through a Slurm interface or through EKS. Now, HyperPod supports both starting this week, with EKS being the new capability. And in case of EKS, you would have an EKS control plane, which is in a separate service VPC managed by the EKS service. That you can think of this as being your controller node, or it's also in Kubernetes terms called the master node in the cluster. You interact with your compute by sending commands to the control plane through a command called kubectl. in your own VPC, you actually don't have any of the compute, but you can store the data in Amazon S3 using a shared volume with Amazon FSx for Lustre, storing your containers in the Elastic Container Registry, and your log information in Amazon CloudWatch. So this is what the architecture looks like. If you want to get step-by-step walkthrough on how to use HyperPod with EKS, we've just published this week Amazon EKS support in Amazon SageMaker HyperPod workshop. So this workshop, will share the link, walks you through step-by-step all of the low-level commands to create a cluster, to run some examples. For example, this is a fully sharded data parallel training of Llama 2 and Llama 3 models on HyperPod. You can also run this against the custom-built accelerators by Amazon called Neuron devices. They're provided by our Trainium instances. And you could also use HyperPod for inference workloads. The workshop ends with teaching you how to clean up everything that you have created as well. And this workshop will be presented at reInvent this year. If you're interested to attend and get hands-on experience, as well as you can do that on your own, in your own account. I would like to show that you can have a homogeneous cluster, but also you can have different instance groups in your cluster if you wanted to have different processors and direct your workloads to different instance types. A full-scale demo of having all of these instances will be published on YouTube video later. For now, I have just a smaller version of this with CPU and A10 GPU instances that I'd like to share with you here.
Yeah, let's see it.
All right. So
Alex, real quick, before you jump into this, we've got another question in the chat. I want to make sure I get to it before we get too deep into this demo. Now, when we're talking about instances, we're talking about EC2, different compute style instances. But we have a question in the chat. Can we run this kind of architecture on Lambdas, or is that's something totally different?
You can run containers on Lambda, but not GPUs or accelerated compute. And when you talk about foundation model training, you do require accelerated compute because the computational requirements of the workloads are so huge that it's just not conducive to basically build supercomputers on Lambda. What we're talking about here is running supercomputers in the cloud.
That's super. So you got a super demo to see some of these supercomputers in action?
Hopefully, yeah. So I cannot possibly get through all of the commands that you need to run within 10 minutes. So I like running things in containers, as I mentioned, and that is why I built this container for you that already has all of the commands kind of packaged in here, and I'm just gonna run through it real quick so we can do this quickly. The project was also open source this week. It's called AWS Do HyperPod and just helps you get started with HyperPod and do things on it quickly. So I've cloned the project here. If you run the build script and builds the container for you, then you run the run script, it starts the container for you. You can see with the status script that the container is up and running. Every time you do something, it actually tells you the actual command that it is running, and we can see this container has been up for 5 hours. I'm going to exec into the container. Basically, I'm getting a shell into this container, and now I have all of the tools in the shell and scripts, like all the automation that's needed to operate and work with HyperPod. So one of the things that that I have here, let me make this screen big, is the HyperPod CLI. So if you don't know much about Kubernetes or kubectl, this HyperPod CLI provides a scientist experience where they can just use this simple command line to look at what compute is available, start training jobs, manage them, look at the logs of these training jobs, and basically operate the scientist workflow against a huge cluster of accelerators, GPUs, or Trainium with this simple interface. I also have some automation scripts here that help you list your available clusters, create a cluster, update it, delete it, and so on. If you like to see things more graphically, there are tools here like EKS node viewer, which show you the distribution of your containers, your pods inside the cluster, as well as if you don't like operating, like typing kubectl commands. By the way, instead of typing kubectl, I'll be just typing K. It's the same thing here. There are many shorthand aliases here, which you can see by typing alias, and that helps save on typing and also reduces the number of mistakes I'll make while talking and typing at the same time.
Nice. Hey, Alex, so we've got just a few more minutes, so I want to make sure you get
All right.
to the core of this. I want to see this supercomputer in action, this containers. We're inside the HyperPod. That's my favorite sentence I've said all week today. Let's see what happens.
It feels like pumpkin spice, doesn't it?
Oh, and everything nice. I like what you did there.
All right, I'm just changing to a model training example here. We're going to run a PyTorch job, and we'll train a very small ImageNet model. We'll apply this manifest. The left one will run on CPUs, and the right one will run on GPU.
Alex, are you setting up a race here? Is this going to be a race?
What's a race?
Yeah, that could feel like a race. So there, I have set it up, one click, and then both go at the same time. And now I am going to watch the pods here on the left side and see they've started running already. So what we'll do is we'll look at the logs of the CPU pods on the left side, and we'll look at the logs using a tool called kubetail. KT is just an abbreviation. The GPU pods on the right side. So
my money's on GPUs.
My money's on CPU.
Has started on both sides, and you can see on the left we have 2 nodes with 4. Actually, let's look at what these things are doing. Getting the nodes here in the cluster on both sides. We have 2 M5 instances. These are CPU instances, and 1 G5 instance, which is contains a single GPU. So if we look at the CPU utilization, and this here is a shorthand for I want to look at this node particular, which is a CPU node. This will show us the utilization for that node. And you can see 4 CPU cores at 100% utilization. This one, if I look at GPU utilization for the G5 instance, which is, it's enough to just identify it with a unique substring of the name. It will show us what the GPU is doing. And we can see here that GPU is being utilized at about 60% maybe, and the memory is even lower because this is a very small model. So though this is a very tough task for CPUs, for GPUs, it's kind of
Yeah. So that's what we would expect. We'd expect the GPU, a little bit more computational power to be running a little bit more efficiently at scale. And we could do that because we can do these things at scale because of HyperPod and some of the commands. Hey, Alex, this is a really awesome demo. And I love seeing this kind of graphical interface in the command line. I think that's like, it almost makes me feel like we're in like an episode of some futuristic sci-fi movie. But Alex, if customers wanted to learn more, where would they go to learn more about this? We got the workshop.
Yeah, so there are a number of resources. Everything that you saw here actually is made by using the workshop, the Do HyperPod project, and the HyperPod CLI. There's the awesome distributed training project, which my team maintains, and it has many examples of how to run distributed training at large scale on accelerated infrastructure.
Very cool. Hey, Alex, thanks for coming on.
My pleasure.